All right, so in this set of notes, we're going to talk about in this set of notes, we're going to talk about element families, element groups, and about valence electrons. So the elements on the periodic table are arranged in groups and families, both groups and families. Okay. All the elements in a family have similar properties. Okay, so for example, here potassium reacts violently with water just like sodium does. All elements in a group have the same number of valence electrons. That's an important point to remember. Okay, all elements in a group, okay, not necessarily a family, although sometimes that's the case. Okay, so valence electrons. Valence electrons are the electrons on the outer shell of the atom. If you remember a Bohr model, on remember the outer shell or the outer orbit is where the valence electrons reside. For example, sodium has 1 valence electron and neon has 8 valence electrons. It is the number of valence electrons that give elements their properties, okay, that predict their behavior, how they act. Some exceptions, okay, and important to understand this, the transition metals, the ones in the middle block of the periodic table, and the lanthanides and actinides, which are within the transition metals. They happen to be those ones that kind of get slotted below or beneath the periodic table because they would make it too wide. They don't follow the same valence rules, okay? The same rules for valence electrons that these groups are going to, that we're going to talk about here. The transition metals are one big family, okay? And the lanthanides and actinides are one big family as well. Okay. So who is this gentleman right here? For those of you who can read Cyrillic, this gentleman's name is Dmitry Mendeleev. Okay, or maybe anglicized Dmitry Mendeleev. Father, he's considered the father of the periodic table of elements. Okay, it's got a killer beard. Okay, so how his worked. So the way that he started the periodic table, okay, he put elements in rows by increasing what is called atomic weight. We now call it atomic mass, okay? But he used that number, because remember that we've got we've got an atomic number and an atomic mass. And so he put them in order according to atomic mass or weight, okay? And he put elements in columns by the way that they reacted. Okay, so he's the one that started organizing it that way. Some problems, okay, he left blank spaces for what he said were undiscovered elements. Turned out he was right, okay. He broke the pattern for increasing atomic weight to keep similar reacting elements together, okay. The current periodic table. So Mendeleev was not too far off. Okay, now the elements are put in rows by increasing atomic number. Okay, remember the number at the top left of each one of those little boxes? The horizontal rows are now called periods and labeled from 1 to 7. Okay. The vertical columns are called groups and are labeled from 1 to 18. So here's where it can get useful, the periodic table. Elements, okay, elements in the same group have similar chemical and physical properties. Mendeleev did that on purpose, okay? Why is it useful? They have the same number of valence electrons. They will form the same kinds of ions, okay? That'll make more sense maybe in grade 10 as well, but important to know. Okay, columns can be grouped into families, okay, or more so groups, okay. Some columns are families. You'll see what I mean. Families may be one column or several columns put together. I guess that's kind of what I'm talking about there. And families have names rather than numbers, okay. So the groups have numbers, the families have names, just like your family has a common last name. And you'll see that on the periodic table that I show you, at least for my class, um, there are certain groups. It's important to understand the groups and the families to help you better understand the table as a whole. Okay, so our first one, and you already saw one metal, that video from the beginning. So the first column on the periodic table, this is group 1, which does not include hydrogen. If you take a look at the top, the very top, hydrogen's at the top. Hydrogen is not a part of this family, okay? It's a part of the group, but not the family, okay? Because they all have one valence electron. But um, these are very reactive metals, okay? And of course, hydrogen is not a metal, right? So um, very reactive metals, almost always combined with something else in nature, okay, like salt. Salt is sodium chloride. Okay, sodium is an alkali metal. They're soft enough to cut with a butter knife. Um, you'll see that in class. And all, again, like I said before, have one valence electron. Here's a video. Okay, so yeah, there you go. There's a video of it. Let's see here. Here's a video of cutting an alkali metal. Okay, and you can see how he just takes a stiffer blade to cut through it. Now I'm going to take I'm going to turn the sound on here so you can hear what they're saying.
Cesium, and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears.
Right there.
Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go down the group, the elements seem to react more quickly with air. Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge.
You won't need to know how to do that formula in grade 9, but you will in grade 10.
Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame. The next element is rubidium. This time we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our fifth alkali metal.
So that one, cesium, pretty violent explosion, as you can see there. So our alkali metals, okay, are these guys right here. Okay, these are our alkali metals. So you can see I've got a color down here. There's a coloring legend down there at the bottom. Okay, and they all have one valence electron. They're in group 1, and they're in periods 2 through 7. Okay, the alkali earth metals. So the second column on the periodic table, or group 2, these are very reactive metals as well, and are always combined with non-metals in nature. Okay, so several of these elements are important minerals, nutrients, things that your body needs. Things like magnesium, calcium. That's why I've got the picture of the cheese and the milk and stuff there. As well to important to remember that they all have 2 valence electrons. And so right here are our alkali earth metals. Okay, they're in group 2 and have 2 valence electrons. They're also in periods 2 through 7. The transition metals. Okay, remember now these ones don't follow the same rules. Okay, but you're still going to know about them. These are elements in groups 3 through 12. Okay, and they're less reactive metals. They're harder metals. These are things when you think of metal. These are the things that are used as metal. Okay, like copper, and iron, and gold, steel. Well, steel's not actually an element, but the parts that are made of it are. Includes, okay, yeah, jewelry, construction materials, and don't follow the same rules as it says down here. Don't follow the same rules as the rest of the electrons, valence electrons. And those are these guys right here, okay? These guys right here. Okay, so you'll notice in the picture that I've got other metals, okay? And so I've kind of grouped these other metals together just to help you understand what some of the other metals are. Because it is important, especially in grade 10, you are going to have to know the difference between metals and non-metals. It's important understanding how they act with one another, okay? And so you can see green, this green one right here. These are the other metals. These are things like aluminum and gallium, okay, and tin. Those are other metals. Okay, metalloids. The metalloids are elements in groups 13 through 16. To the left of the staircase are metals. To the right of the staircase are non-metals. That's what that should say right there. And metalloids are on the staircase. Okay, so what is the staircase? The staircase goes right here. Okay, you can see that they follow the staircase, right? These blue guys right here, these are the metalloids. Okay, and they follow the staircase. To the left, it said, are metals. To the right are non-metals in groups 13 through 16. Non-metals, okay, these are elements in groups 1 and then 14 through 16. So we have, of course, hydrogen right here, a non-metal, okay? And then if we skip over here from 14 through 18, okay, we have the rest of the non-metals. And we would say they are to the right of the staircase, okay? And you'll notice the valence electrons depend on where they fall. Now let's just quickly talk about hydrogen a little bit more. So hydrogen belongs to its own family, although it is part of the you'll see it kind of fit into a few categories there. It fit into both the group. It fits into group 1. Okay. It also is a gas. Okay. It's also a non-metal, right? See, it's the same color as the rest of these guys. It's also a non-metal. Okay. So hydrogen is a diatomic reactive gas. That means that in nature, di means 2. Okay, so that in nature they're together. They always hydrogen usually comes as in 2s. Okay, hydrogen was involved in the explosion of the Hindenburg. That's what this picture is. This, very tragic event. Uh, because hydrogen causes, just like helium will cause things to float. It was used, and it's a very good fuel source. Um, it was used for the Hindenburg. However, because it is very explosive and reactive, it did actually. Well, of course, you can see the explosion here. And hydrogen is a promising and alternative fuel source for automobiles. It has one valence electron. Yeah, actually, you can go to the King of Random, or there's all kinds of different places that you can build hydrogen generators just with household parts. It's kind of interesting. Not that I recommend it, and not that I do it myself, but because I don't have any need to do that. But you can, right? And so, of course, here's hydrogen with one valence electron in group 1 and period 1. The boron family. Okay, so now we're going to talk a little bit more about a family. These are all the elements in group 13, and so we lump them together. Now, I don't have them written out this way on your periodic table, but it's important to know them. Okay, so aluminum is part of this group and was once a rare and expensive metal, not a disposable metal, but of course it is, we know it's very abundant. Everybody in the boron family or group 13 has 3 valence electrons, right? So if we take a look over here, this is the boron family right here, okay? And in the boron family, because boron is right here, which is group 13, all have 3 valence electrons. Okay, the nitrogen family, elements in group 15, okay? Nitrogen makes up over 3/4 of the atmosphere. I believe it's 78% of our atmosphere. The gas in our atmosphere is nitrogen. But I think it's 20 point something, 20.8 or 21% is oxygen, and then there's a bunch of other, and then of course a little bit of carbon. And nitrogen and phosphorus are both important in living things. Very important. Your body is made up of these things. Okay, your DNA contains nitrogen. Most of the world's nitrogen is not available to living things. Okay, you'll find out more about that in grade 10. We'll talk about the nitrogen cycle. We won't hear so much, but it's important to know. The red stuff on the tips of matches, okay, phosphorus, and they all have 5 valence electrons. So if we take a look here, okay, we have the nitrogen family. They all are these guys here in group 15, and they all have 5 valence electrons. Now I just realized I skipped. I must have had it, I guess, after this slide. But the carbon we're going to go into next. Yes, of course, there it is. I guess this should have been before, but that's all right. Elements in group 14, okay, are in the carbon cycle, or the carbon family, and they contain elements important to life and computers. So carbon, so carbon is the basis for an entire branch of chemistry, and and that's what this kind of implies, we are a carbon-based life form. All life on Earth is carbon-based. Okay. Also, computer chips are made with semiconductors, things like silicone and germanium. Okay, and semiconductors help um, to allow us to have these tiny little computers in our pocket, these cell phones that allow processors to transfer information so quickly. Everybody in the carbon family, or group 14, has 4 valence electrons. So this is the one that we skipped, okay? But here we go, 4 valence electrons, group 4, carbon family, okay? Periods 2 through 7. Okay, the oxygen family, or the chalagens, okay? Elements in group 16 for this one. Oxygen is necessary for respiration. Of course, we know that. For breathing, you need it to breathe every single day. Many things that stink contain sulfur, okay, which is also in this family. Rotten eggs, garlic, skunks, okay, their odor. These things um, contain sulfur, and everyone in the oxygen family or the chalogen family or group 16 has 6 valence electrons. So here we are right here, 6 valence electrons, group 16 or the oxygen family or chalogens right here. Okay, right there. Okay, now the halogens. Okay, these are everybody in group 17. These are very reactive, volatile, diatomic. Okay, remember di means two. So these guys all come in twos. These are all non-metals. Okay, and they're always found combined with something, with other elements in nature. These things can be used as disinfectants and to strengthen your teeth. Of course, you've got fluoride. Okay, and they all have 7 valence electrons. So take a look here. Okay. These are our halogens right here. Okay. It's group 17, 7 valence electrons. They're all diatomic, meaning they all come in twos in nature. Okay. Now on to the noble gases. Okay. The noble gases. So these are elements in group 18, very unreactive, monoatomic. So they come in singles. Okay. Gases used to light up neon signs. So neon is one of them. Used in blimps to fix the Hindenburg problem. That is helium. Okay, and they all have full valence shells. So if we take a look here, helium is in period 1. Okay, and for your Bohr models, you'll know that that means it only has one shell, and on the first shell, you can have no more than 2 electrons, and so that means that helium only has 2 valence electrons, right? So we don't say that this has 8 valence electrons because that's not accurate. Okay, we know that neon and argon do, and that's really all that you need to worry about is, as far as this class is concerned, is the first 18, maybe 19 and 20 as well, but specifically these ones are the most important. Okay, and so right here, these guys, mostly gases. Okay, monoatomic, full valence shells, means that they can't combine with anyone else in nature. Okay, there's no extra room on their shells. Okay, it'll make more sense as we go on. So now I want you to pause and test yourself. Okay, so we're going to list the valence electrons for each element. So if you need to get the get out your periodic table and and go along with me. So find argon. Identify how many valence electrons, and make sure you pause throughout this. Okay, that's right. So if you said it has 8, then you are right. Potassium has 1. Boron has 3. Carbon has 4. Nitrogen has 5. Remember, how do we figure that out? Right? Well, boron is right here, right? Boron is in group 13, which has 3 valence electrons, right? Carbon is in group 14, which has 4. Nitrogen has 5, okay? Argon is full, and it has 8, okay?